Anyone? Um, did we see the projection method last class? Any idea? All right. So okay, that's no problem. But how many of you checked those instruments, mini drafter especially? Did you check with the stores and already bought it? Can anyone already did buy this uh, the instruments last class I mentioned? You have any problems? All you got your projector, I mean the mini drafters already? Good, good, good. So the other day I visited Jarir. So I've seen the Jarir store in Thalia Street. They kept every many of these mini drafters outside as an exhibition. So I've seen it in the Thalia Street Jair, and I don't know about the other stores, but online also you can purchase from online. Amazon also giving the Jair also. So please check this out and buy it as soon as possible. Because this week and next week we'll be having this theoretical session, and right away we will be starting our practical session. All right. So I hope all of you purchase this as soon as possible. Okay. Don't loan from someone, or do not. If you do not buy it, maybe next week I'm going to give you one exercise, and that exercise you have to finish it within 3 hours. So if you don't have any instrument on your own, it's extremely difficult for you to finish it within the time, and Blackboard will not allow you to submit your exercise once you exceeded the time limit that you have been given. So be a little careful. Um, so try to buy this as soon as possible. Okay, there are 27 of us here. Anyway, so let's start with this projection method. If you remember last time, what is a parallel projection and orthographic, axonometric, and multi-view? You all remember this, right? What is the difference between parallel and perspective? Perspective, in a sense, it does not show the real shape and size based on the convergence of a human eye. But however, this could be useful for those professionals who worked um, in the field of animation and the games. But for professional engineers like us, we do not use this perspective projection method, but instead we are using parallel method. Okay, that I think we have seen in the last class. So I hope you remember this. The line of sight, plan of projection. This all these things we have seen last class, right? You remember this? Okay, right. Okay. Then in fact we have this also, and I showed a video also. We have seen the video as well, right? Did you see the video? How the perspective view and the parallel view. Oh yeah, that's right. So I mean, then this is a particular group we have seen. Someone say no. Really? You didn't see the video for perspective view? Not yet. Why? Really? Were you absent last class? Yeah, the building. The building. Yeah, not the building, but there is one more. Let me. It's something like there's a small there's light, and this light projection is being shown there, and there's something like that. I hope you know that. Correct? Yeah. Okay. Okay. Can we see the again? You could because that hardly takes time. But anyway, let me show you. But not necessary. Anyway, if time permits, because since we have seen it, we do not have much time. Later, maybe the next hour, once we come out of the break, I will show you that first 5 minutes. I will show you. Okay. Then before everybody and after the prayer. Then we can see that. Okay. So orthographic projection we have seen. This is a parallel projection, and now this also we have seen depends on the two dimensions of the object. How you see parallel, you will get those particular what do you call it, surface will be shown here. So this is what you are going to see, and exactly the same size and shape, provided that you see your line of sight should be parallel to the edges of the particular component. Okay, that's how it works. But interestingly, if your line of sight because your line of sight is parallel to the edges, if the edges are somewhat uh, you know like this, if it is rotated, then you will see there will be one, two, three edges, and these three edges have different. When you see this, the thickness will be different because you see from this angle, and all you can see is this surface is now inclined. So this what do you call it, surface, based on the edge, this distance or the width of this surface will be very different from this surface. Do you visualize it? Why so? It's supposed to be the same thickness, correct? But when you see it from the front view, these thicknesses are not the same. Why? Anybody? Do you understand what I'm trying to say here? When I see a component surface parallel to the edges, I mean the eye, eyesight side of the eye and the edges are parallel, then you will get a very similar shape and size of the surface based on the edges. But if I could see the same object slightly rotated, then I could see not two edges, but this time three edges. One, two, now this is the edge one, edge two, and edge three as well. So that time, based on your vision, the thickness might vary. This is a very, very important aspect of orthographic view. So most of you make a mistake in the exam. Suppose if I give this same problem to you and ask you to draw the front view, top view, and side view, and most of you usually make mistake here. Do you understand what I'm trying to say here? Correct? Let me show you. I don't know. Do you understand what I'm trying to say here? Okay. Yeah. Right. Right. So that's why, as an engineer, you should be very very careful in visualizing the surface what you have seen. The idea is you just keep your eyesight parallel to the edges, but if the object rotates slightly, then you will see different edges. Then based on the edges, you should draw the view. And remember, this view does not show the actual width in that case. So that is very important to remember this. So if they give a shape like this or a projection like this, it doesn't mean that sometimes if you see that, you mean that we need to memorize the shape. No need to memorize the shape. You need to visualization. You understand? You have to visualize it. How does it look like? You have to imagine. Imagination is very, very important for engineering drawing. You have to imagine, you have to visualize it, then only you will understand how does it look like. You know why? Because this view will be watched by other engineer, and he should also understand the shape very similar to what you are. That's why we are keeping this as a standard. Okay, later you will see. But for the time being, the way you look at the uh, you know um, this view will be very different if this is parallel or something. Guys, don't do that. Don't do that. Who draw this? Don't do that. Okay? Don't interfere with the presentation. Okay? That'll be difficult. All right. Okay. Now, orthogonal view is a multi-view drawing. It's a projection technique, and that show all the three dimensions of an object in one view. That we call it as axonometric drawing. So, multi-view drawing is what we call the object is in two dimensions. Axonometric is three dimensions. Is that understood? You don't need to remember all this, but you just remember there will be two-dimensional drawings and three-dimensional drawings. If it is two-dimensional drawing, that is multi-view. If it is three-dimensional, that will be axonometric drawing. Okay, both are used. Now I'll give you an example for an axonometric drawing. Now you see here. This is a three-dimensional view. So obviously this should be axonometric because axonometric means three-dimensional. Why it is three-dimensional drawing? Because in a 2D paper, two-dimensional paper, this will give you the length and width as well as height. So these three dimensions are given in one in a two-dimensional paper. So that's why this is a three-dimensional. We call it as isometric drawing, or otherwise you can say axonometric drawing. That means the particular drawing will be given all the three dimensions possible in this. Okay, and the problem with this axonometric means the shape does not look the same. Remember, this is a circular section, but when you see through an axonometric or isometric view, this looks like a ellipse. Do you understand why? It's an ellipse, not it is shown as ellipse, but it is not. It is actually circular. Is it correct or not? It is because of this. It is because of this. You see, although this is a rectangular surface, but when you see it with the rotation, you could see two surfaces. It's not the object's fault. It's your eyes, the eyesight. So the eyesight depends on your eyesight. You could see three edges or two edges. Axonometric means 3D. Yeah, it's 3D view. Yeah, multi-view means only 2D, but uh, axonometric means three-dimensional view. Okay, good. See, one student is keep on asking me online. That is the way you have to communicate with me. Just don't keep yourself just be there. Okay, this is the time for me to take the attendance. Let me check the attendance now. I think 32 people are here. Let me see. We'll finish it because I want to check how many of you attended today for me to give you the what do you call it your um, grades later. Okay, so let me see how many of you are here today. Okay, just a semester. All right, just give me a second. Let me see. Let me see. There are all of you are now attending, so that's a very good thing. I'm very happy. Uh, Now let's see. You have seen it now, right? Okay, you can see that now. This class is 18874 this is 7377. Oh no, it's 14968. 14968. So let me take the attendance now. Yeah, 14968. Okay, 14968 engineering drawing, and today is Monday from 5 to 7. Okay, let's go for the attendance now. Okay, let me call your names. Please answer your attendance. Anas Hatim Saad Ali Hamda. Okay. Muhammad Taha Muhammad Afalata. Muhammad Talha Muhammad Fallata. Can you see this? He is absent today, correct? Okay, he is absent. Abdullah Majid Obaidullah Al Khurairi. Abdullah Majid. Okay, present. Muhammad Abdul Khalik Abdullah Yahya. Muhammad Abdul Khalik Abdullah Yahya. Okay. Abdulaziz Sulaiman Obaid Sankhol. Abdulaziz Sulaiman Obaid Sankhov. Absent. Obaid Sulaiman Obaid Sankhov. Absent. Rayed Abdulaziz Uthman Al Mazal. Okay, present. Osama Naif Habib Ala Al Salma. Khalid Muhammad Jabir Al Bukhairi. Abdul Majid Zayed Asiri Al Zahrani. Okay, he's present. Okay. Ryan Ahmad Abdullah Aziz. Ryan Ahmad Abdullah. Okay. Ahmad Aziz Al Nujibi. Okay. Abdul Rahman Muhammad Atalla Al Anzi. Abdul Hadi Jalabi Abdul Hadi Al Khathani. Abdul Hadi Jalabi Abdul Hadi Al Khathani. Absent. Hasan Jarallah Ubaidullah Al Tuwairki. Present. Very good. Let me see how many of you here. Abdullah Muhammad Abdul Al Asmari. Okay, present. Muhammad Manzoor Hamdi Nadim. Suhaib Ali Hussain Saleh. Sultan Saad Hamid Al Harti. Muhammad Abdulaziz Hussain Al Mahya. Muhammad, okay, Muhammad present here, okay. Adnan Wissam Adnan Barasi. Adnan, okay. Ziyad Abdul Salam Hamadi Al Jaddani. Not here? Okay. Badr Abdullah Omar, okay. Asil Ali Hassan Al Zarani. Iyad Abdulaziz Awad Al Zahrani. Faris Ali Hassan Abu Khamas. Yusuf Khani Abdullah Majid. Ahmad Salim Hassan Al Harti. Abdulaziz Abdullah Hussain Al Marshidi. Talal Al Hussain Hamadi Al Sharif. Sultan Muhammad Abdul Munaim Al Salami. Al Hassan Allawi Hassan Al Safi. Abdullah Ayman Hussain Kamflo. Ali Hassan Ali Al Shahri. Okay, 34. So the absentees are today Abdul Hadi Jawali, and then Ubaid Sulaiman Ubaid Sankhi, Abdulaziz Sulaiman Ubaid Sankhi, and Muhammad Taha Muhammad Fallata. So there are 4 people absent today. I am going to execute it. Okay, that is the attendance. Thank you very much. All right. So, okay, if you have any doubts, later you can. Okay. All right. Thank you so much. Now let's go back to our discussion, because I just want to show uh, this very important. Why I insist, guys, don't worry. Usually I take the attendance for you to give you some credits in case if you attend all the classes. That's why I'm taking attendance every day. And remember, Blackboard also taking the attendance, but usually if it is 10 minutes late, then Blackboard will consider you absent and it will send this information to the department. Okay, now as somebody rightly pointed out, Axonometric means isometric drawing, and which shows you all the three dimensions here. All right. So now this is multi-view drawing. In the multi-view drawing, it represents accurate shape first of all. That's very important. Okay. So the accurate shape means this will show you the parallel uh, projection actually, and it required practice in writing and reading. And this is how the multi-view drawing works. Two view drawings. If this included, that will be axonometric or isometric, but this is different. Here you see only the length and height can be shown. Width, you have to put it in another view. Okay, now if you see, this is the length, this is the height, and this is the width, but the same thing, they are using it in two dimensions. But in a isometric view, everything is shown here. So now this is the length, this is the width, and this is the height. So all together in one single view, then that is isometric. Okay, this one is isometric view, whereas this one is a multi-view drawing. Do you understand now? In order to show the same length, width, and height, here we need two different drawings. One is the front view, another one is the right side view. Correct? And the length is shown here. The same drawing, because these three drawings are actually show the same component. But the advantage here is, in the multi-view drawing, you can see the circle as it is. But in an isometric view, the same circle is now distorted and it shows like a ellipse. So an isometric view does not show the accurate shape and size absolutely, whereas a multi-view drawing will normally show the exact represent accurate with an accurate size and shape. Okay, and that's the difference between these two. And remember, both these methods are showing the same component. That's very important. Do you understand what I'm saying here? Okay. Now, there are several standards, as I mentioned earlier, because I told you, like I said, why you need different standards. I remember last class I was mentioning an interesting story. Why we need different standards? Because you see the standards in USA, American National Standard ANSI, and JAS, Japanese Standard, the British Standard, the Australian Standard, Germany DIN, and international standards. So these are the shortcuts for, yeah, right, you're right, for the standards. And each standard has its own, uh, we can say some standard procedures in order to show the drawings. So most of the time we are following the ISO standard. It's an international standard. But when I was in industry, we normally use the US, always use the ANSI standard. And this Japanese always follow the JA standard. And the British, I don't know, but I never used the British standard, but I always use the ANSI for the, the USA. And DIN also I have used because this is popular in the Europe, especially German. Germany is generally using this standard. All right. Okay. Okay. Now the drawing sheet, very important. I'm sure most of you must have purchased your drawing sheet now, but those who do not until now, just check. These are the standard sizes of a drawing sheet. Okay, this is the standard size. A4. This is the one now you're using for writing your notes, your notebook, or the documents. This is the standard documental. This is standard document. And what is A3 is our standard for engineering drawing. Okay, so this is the standard. I asked you to buy this because most of your exams you must use this particular drawing sheet. A4, unless I ask you, most probably you'd use A3. and sometimes A4 maybe in your, if the drawing is a small one, you can use A4, but as a general practice we normally use A3. A2, A1 is already used, but not for you. This is for the industrial standard. In those days, in industry, there we are using these big sheets. Okay, now as per the Japanese standard, A4 means it is 210 by 297 millimeters, and A3 is almost 300 to 420 millimeters. That's the size of an A3 sheet. You understand? Now you see here, interesting is, as the number keep on increasing, A0, A1, A2, A3, and A4, the size is keep on reducing. That's the idea. Okay, A1 is bigger than A2, right? In a true sense, but in the paper size, A2 is smaller than A1. That's the thing. When the number is increasing, the size of the paper is indeed decreasing. That's the one something you should remember. So when they say A0, it is because do we need to memorize the size? No, you don't need to memorize anything in this class. I guarantee you, you don't need to remember, memorize, read. Oh no, no, not at all. You are required to understand. That's very important. You require to understand, and here you need to develop your skills by knowledge, by developing your knowledge. So no need to memorize. Don't ever memorize anything here. So here the most important thing is skill. You are required to draw with skill. That's what required from you. You don't need to remember what is A4, what is A3, what is A size. Who cares? Just go to the Jerry's shop and tell them I need A3. Fine, that's it. I need an A4. Fine. But the point is, as an engineer, you should know A0 is bigger than A4. That you should remember. Okay. You go there, and when they say if it is A5, A6, those are non-standard, but still, if they say A6 means it's a very small paper, right? Some receipts normally you make the receipts, so those papers are even very small. So that means the size should have been A6, A7, or something like that. A4 is A4. Okay, good. So clear? No need to memorize. Please don't. I will never ask you what is the size of A3, what is the size of A4. Never. You have the cell phone, you have the smartphone, so the smartphone will give you everything, right? So you don't need to remember. Don't worry. So the orientation of the drawing sheet should always be oriented like this. This is very important. All right. So when you purchase the A3 sheet and we are going to prepare for your drawing, your orientation should be always landscape orientation. They say landscape. You must have seen it in the what do you call it? Word, MS Word, Microsoft Word. You must have seen it. Landscape, portrait. So this is the portrait. This is the landscape. So A0 to A4 for a drawing sheet, it should be always oriented with the bigger length on the bottom, the smaller one on the vertical side. And you should always give certain distance here, in order to put your mini drafter, to fix your mini drafter. And so uh, this this gap between, the C must always be constant, and D is slightly higher or greater or bigger. Very similarly, if you put a portrait, again the D should be comparatively smaller, while the rest all should be kept constant. Do you understand what I'm trying to say here? This is how you have to orient a drawing sheet whenever you start drawing components here. Okay, so the size is here is an A4. It is 10. That means this is 10, 10, and 10, whereas D is 25. So irrespective of the sheet, always this length should be 25, and this can be, it should be constant. Don't worry about it. It just makes sure that C's are constant, but here at least you provide an inch, 1 inch, which is 25.4 mm. We normally in the industry we give 1 inch at this side. Okay, generally this is for binding, because when we keep the record, all these sheets will be kept in a paper, in a file. Then this is required to keep a record. Okay, it's very easy thing. And here you draw the title block. The title block, we will discuss it in details later. We write what is the name of the drawing, the dimensions used, the standard used, whether you are using a JIS standard or DIN standard or American standard. All these things will be provided here. Okay, this is the area where you put the specification of the drawing, the name of the drawing, the component, the type of view, everything here. In case of a A3 sheet, this is like that. In case of an A4 sheet, this should be here. Okay, all right. Okay, so that is how you orient a paper, a drawing sheet especially, for engineering drawing. The next important thing is scale. Scale, what is a scale? Any idea? I told you scale is the ratio of the linear dimension of an element to the real size. Remember, the engineers are trying to make drawing of a building, and the building is so tall, but your paper is just A3 sheet. So you have to represent this big building in a small piece of paper. So what you do, you just say you can make this with your scale. Very similar. If you use a map of Saudi Arabia, and map of Saudi Arabia shows the entire country in a paper, but the paper is very small. So we make. That's why when you check the map, in the map they normally give the scale 1:100,000. This is the scale for a map. That means in the paper, 1 millimeter is in the actual scale. It represents maybe 100 kilometers or maybe more. So that way you represent the actual one to scale down, minimize. Yeah, not minimize, but that's the most technical word for an engineer. Minimize, maximize is, I don't know. I don't think that is the right way of representing this. But we use like scale. That is our traditional terminology for any engineer. So engineers normally check the drawing and they say, what is the scale? Okay. So scale up or scale down. Do you understand what I'm trying to say? The actual size is bigger, but the one you showed it in the paper is smaller, and this should have some relationship. So you say my scale is 1:2. That means if the scale actual size is 2, I represent it here is 1. If it is 2 meters, here I'm showing it 1 meter. If it is 2 meters, I'm showing it in 2 millimeters. So the scale is 1:10, 1:20, 1:100, 1:1000. All together, this is all scale up and down. All right. Um, extent. What do you mean by extent? I don't know what you're talking about. Extents, or I don't know. So now just go a little further. Drawing scale. So it consists of a scale. That is our and it is actually the ratio. Yeah, this is the right word. Ratio. 1:1 means full size. That means the actual size is 1. You are also showing 1. So that is full size. Synonymous, no, no, those are synonymous, anonymous, no, no, those are literal terminologies. We don't use it in engineering. We are practical people. We are not using those synonyms and all this. For us, it is scale. Okay, don't go for synonyms. Synonyms are generally meant in a literature uh, regarding those names, or the meaning of words. Okay, so that's, you should not use it here. Okay, so if someone draw 1:1 scale, means whatever you draw, it shows exactly the same size of the original component. And scale exists to one means it is enlargement scale. That means this is more than one. The original scale is less. Now you are increasing it. Reduction scale means original scale is bigger. You are reducing it. So full size, enlargement, and reduction scale. Can you give me an example for this? True scale, enlargement scale, and reduction scale. I'll give you an example so you'll understand this much better. Okay? Let me see how can I. Okay, now you see, I am a as an engineer. I draw, yeah, what do you call it? Smartphone. Let's say iPhone Pro. iPhone Pro. You want to draw the iPhone 11 Pro. So iPhone 11 Pro, if you see, is more or less like maximum 20 to 25 centimeters. It will be maximum 25 centimeters, not 25, maybe 15. Okay, just approximately, just consider it is 25, and this will be around maybe 10 centimeters. Okay, so this is the size of an iPhone. Let's say this is iPhone. So if you want to make a drawing, then you can directly make a drawing with the true size. Correct or not? So take a paper and write it here. This is iPhone 11 scale. Now what is the scale here? What is the scale I am using here for the iPhone? Full scale, correct. So this is 1:1. Full scale. Excellent. This is full scale because I can put this in a paper, because iPhone and A3 paper size is almost, I can still make it, and I can draw the, like this. If it is like this will be an isometric view, because 3 dimensions. Okay, so this is an isometric view and full scale. Suppose the next thing is I want to draw, a, let's say, a building in Cornish Road. So this is the building, and the building is shown here in the Cornish. So you are drawing this elevation and some. This is the building of Cornish factory, Cornish in the Cornish Road. So if you want to draw it in a piece of paper, can you draw the full scale here? Absolutely cannot, because your paper is even smaller than the a single, uh, a window of this building. So what I'll do here, I will draw the same building like this, and now this is the tower. Let's say Cornish Tower. Okay, Cornish Tower. So the scale, what is is it true scale or reduction scale or enlarged scale? Anyone? So this should be reduction scale. Excellent. Yeah, it should be reduction scale. And how much I reduce? Now this will be, if the original is 1, then this should be like 0.00001, something like that. Okay. So if I put 0.0001 meters, then this will be show 1 meter. So this is the ratio for reducing the scale, and still I keep the shape, but the scale is different. So this is the reduction scale. So that, I think now you understand. I suppose if you want to make a drawing on a small, let's say, a battery. So the battery, when you buy from the from the shop, this battery is very small. So what I did, I make a drawing of the battery. This is the battery. Now in this battery, this is, yeah, go on, Maxwell battery.
Doctor, can we use the enlarged size for this building?
How can you? You need a paper more than bigger than the building.
Because I didn't know what the difference between the rejection and enlarge.
Okay, you want to show the building, right?
Yes.
So when you want to show the building in a paper, if it is true scale means the paper and the building has the same size. Cannot. Suppose if
So if
the
the
iPhone size is 25 mm, so here is 25 mm. I can have some shape in the paper. So paper is bigger than the iPhone, so I can still make it. But when you consider the big building, my paper is very, very small, smaller than the window of the building. But I still want to show the building. So I reduce the scale. I make the buildings very, very small so I can put it in a paper according to
so
scale. So I am reducing the original size to some scale. And remember here, each one mm represent here like 10 meters or 100 meters. It is like a map, the Saudi Arabian map. Suppose if this is the map, let me show you
mhm.
the map. If the map shows you Saudi Arabia is like this, right? But Saudi Arabia is such a big, huge country. But you put it in the paper. Here it is Jeddah. So what I write,
So
I make the drawing in a paper and write the scale. I'm reducing the scale of Saudi Arabia to maybe 100,000 times. Okay. So
so
here
if
you
the
have
object is
to,
bigger than the paper, we use the
uh,
reduction size.
correct, absolutely correct. If the
Mhm.
object is very, very small so that you cannot find anything when you write the true scale, then you enlarge it. Suppose if you want to draw a mosquito, what do you do? A mosquito, small mosquito, you want to draw. Can you draw a mosquito on a paper? You cannot even see it. So you enlarge it to 10 times, then you draw the big mosquito here. So now that is an enlargement scale. You understand?
Yes, yes,
Good. So this is what then enlargement scale, reduction scale, and full scale. This is extremely important for engineers to remember this, and that's how you can read the drawing. And always, if the drawing you can measure it. Okay, you take the drawing and measure this distance, and if it is 1 mm, then you say in the original drawing, in the original shape, this will you multiply with the scale. If it is 100 is to 1, so if I put it here, 1 means it is 1 by 100 time in the original size. In case of an enlargement scale, here 1 mm means the actual Saudi Arabia has 100 kilometers. So if I draw a road in a map from one place to another, so this just measure 1 millimeter, then you use the scale and calculate the distance directly. Okay, if it is 1 mm, the actual scale is 100 kilometers. Do you follow me?
yes.
Good, good. Okay, let's go to the you know. All right, it's very nice that people are asking questions now. Good. So now you see we are now on into the scale, and let's see, we are on scale. So that is how scale 1 is to 1 full, some x is to 1 is enlargement. That means here it is 20 times means actually it is smaller. If the original scale is 1 and here you are reducing it, 1 is to 2, 1 is to 5 means it is half of the scale. Okay, that is how I have to find the size. So dimension numbers shown in the drawing are correspondent to the true size of the object independent of the scale. So to create this drawing. So this is also a very important factor you should remember. Okay, the next most important thing is the basic line type. There's a continuous thick lines, thin line, dashed line, chain thin line. Okay, so I remember last time I was mentioning about the lines. Let's see the video that will give you an idea about the lines. Well, last class, did I mention? Did I show it to you? I don't think so. Let me check. There was. Let's see. It's regarding the. Right. Okay, here are the lines. The different lines. Let's see. Okay, I will show you that movie. Somebody asked me last time, so I'll show you this again. Okay, we'll see it again now. Uh, what are the types of lines? So if you see the video, this will be much useful to you guys. Then first watch it, then we'll see. Okay, now let me show you the video. Watch it very carefully, then we'll see. And of course, can you hear those? The audio don't hear, right? You don't hear the audio? You don't hear the audio, right? So let me show. Okay, let me. Right. Wait. Yeah. Okay. I can. So because that's very important. How can I make this audio? Still, you cannot hear the audio, right? Let me see. Let me see. Okay, stop sharing and then when you. Yeah, wait. Share audio. It should be fine. Don't worry. I know that. Don't worry. I know. Okay, I designed the laptop, so don't tell me. All right. Engineering drawing. Okay, now you see here. Right. So now you watch this
In
very
this Easy
carefully.
Ed video lecture, we will learn what is engineering drawing, drawing instruments and its uses, and lines and types of lines. First, we will see what is engineering drawing. Engineering drawing is a type of technical drawing which is used to clearly define the requirements for engineered items such as views, dimensions, and necessary information. More than drawing pictures, it is also a language, a graphical language that communicates ideas and information from one mind to another. Most important, it communicates all needed information from the engineer who designed a part to the worker who will make it. Application of engineering drawing is used in ships, manufacturing, aerodynamics of automobiles, constructions, etc. Let us see different drawing instruments used in engineering drawing. In this we have a drawing board, drawing paper, pens, clips, or adhesive tapes, pencils, T-square, set square, scale, drafter, roller scale, protractor, French curves, compass, and eraser.
Hey, it's time to concentrate now.
Now let us describe each and every instrument. Drawing board is rectangular in shape and is made of wood about 25 mm thick. It is cleated at the back by two battens to prevent warping. The surface of the board should be smooth and it is used to keep the drawing paper. There is a working edge at the side of the drawing board. While selecting a drawing paper, we have to be sure that the size of the paper is smaller than the drawing board. To hold this drawing paper, we use pins or clips or adhesive tapes. Pencils are basically used to draw. The accuracy and appearance of a drawing depends on the quality of the pencils used. The grade of pencils, H, 2H, and HB are mostly used. Next is the T-square. It is made of two parts, the stock and the blade, which are joined together at right angles by means of screws and pins. T-square is fitted at the side of the drawing board and it slides along the edge of the board and is used to draw horizontal straight lines. Set square is triangular in shape with one of the angles as right angle. Two forms of the set square are generally used, one having angles 45, 45 and 90 degree and the other is 30, 60, 90. Set square is a combination with T-square is used to draw lines at an angle. A scale is used to draw lines of specific length. Protractor is flat and semicircular in shape. Its circumferential edge is graduated to 1-degree divisions and is numbered at every 10-degree interval and is readable from both the ends. The protractor is used to draw or measure angles. The combination of a T-square, a set square, scales, and a protractor is a drafter. Its one end is clamped by means of a screw at the edge of the drawing board. The other end is adjustable. It has a scale which is at 90 degree and also has a protractor which can be rotated at certain angles. This scale can be moved anywhere we want within its limits. Next is a roller scale. It has a roller in it. It is used for drawing vertical lines, horizontal lines, parallel lines, angles and circles. Next instrument is the French curve. They are made in various shapes, one of which is shown here. French curve is used for drawing curves which cannot be drawn with a compass. It is used to draw curves like ellipse, parabola, hyperbola, etc. A compass is used to draw a circle of a specific radius and an arc at a specific distance. Soft Indian rubber is widely used to erase pencil drawings. The eraser should be such that it does not spoil the surface of the paper. Next, we will see lines and types of lines. Just as in any textbook, we are taught to use the correct words for making correct sentences. Similarly, in engineering drawing, the details of various objects are drawn by different types of lines. Various types of lines are used in engineering drawing. Now let us see the different types of lines. First is a continuous thick line. This line is used to display outline and edges of the main drawing.
Okay, so that is what he's mentioning. Any thick line. So this thick line should be used for mentioning about the edges of a particular component, and it should be dark. So normally, what I would suggest, you have to use the HB pencil, which is darker pencil, to show the edges of a component. Remember, there are several lines you have to draw. You have to clearly show the distinction between these lines, the difference in these lines. So whenever if you find any thick line, that means that is the edge of a component. Thin lines are generally used for some other purpose. That's why whenever you draw the line thickness, dark line, light line, is it a straight line or a axis line or maybe a dotted line? All are very important. The engineers will understand about the component by watching the line itself. By watching the line, he say, okay, this is the size, this is the shape of a component. And from the line also he see this is an axis line or this is a hidden line or and so on. Okay, so understanding about the lines is very important for every engineer, especially the mechanical engineers and all the engineers. Not really for the electrical and electronics. It's not much useful, but for mechanical engineers, this is extremely important to check how you are using it. And in all your future exercises, exams, I always check whether you have used the lines correctly. If you don't use the lines correctly, naturally you will lose marks. So you should be very careful. Thick, dark lines must be only used to show the outer edges, boundaries of a drawing. You should not make this line darker when you make such lines, the hidden lines and other lines. So clearly, the line should show this is the boundary, this is the edge of this component. That's the idea here. That we call it as thick line, as you see in the video. Okay, go on.
Next is the continuous thin line.
Thin line.
This line is basically used for dimension, extension, projection, leaders, hatching, etc.
So thin lines are used for the dimension line, for the diameter, and for the projection lines, and so on. So thick line is the actual line of the component. Thin lines are for understanding the dimensions of the particular component. So you should clearly show the difference between a thick line and a thin line. You should never ever confuse a thin line to be the actual component. It's not. It's not. It's wrong actually. So you have to clearly mention, use the lines very clearly, and such that any engineer when he see this he will clearly know. Okay, this is the dimension line, and this is the actual line. Okay.
Next is a continuous thin freehand line. This line is used to show short break or irregular boundaries. Next is the continuous thin line with zigzags. This line is used to show long break. Next is the dashed line. This line is used to show
Wait.
hidden.
So, do you understand what is this short break line? I'm sure you must be wondering what is this short break line, right? I'll show you how. Okay. Um, let's uh, let's see. Can I draw it somewhere here? All right. How can I? I will draw here. Suppose if you say, yeah, this is call it. Let's say you have a railway railway line. Okay, this railway line is like this, and this is the train. This is how it works. So this is this particular shape is throughout the shape. This is the same size and shape. So in order to show this railway line, I say this is 1 kilometer length. So 1 kilometer means actually this 1,000 meters. 1,000 meters you cannot draw in a paper. You know what you said? Okay, this is the actual size of this, and you break it here. Okay, you break here. Okay, let's see how can I break it. I don't know. Okay. So what I will do, instead I will make it like this. So this is a line, this is another line, and here I break it. So this is the line, and here again I make it. So this is breaking of these two, and I say this is the same, and I put now here. This is the size is 1,000 meters. So here I clearly mention the size is the same throughout, but I break it, but the total length is 1,000 meters. Do you understand what I'm trying to say here? So since this is the same size, I break it. So that's why we use the line. This is break line. Something you must have seen it somewhere. Okay, these are the lines. Whenever you try to draw the very big sizes of the same size and shape, we normally use this one. Okay, now you see here. Can you see this
Doctor,
video? Yeah, yes.
what's the purpose of the short line, or the shortcut line,
What?
or the short break line? What's the purpose of it?
Yeah. The short break line, that's what I was saying, because if the size and shape is the same, and you don't need to provide each and everything because this is the same size throughout.
But
So
in the beginning of the video, that's is the thin
scaling
line.
down, scale. You're talking about the scale.
No, I was saying that the thin line, it is, shows the size of it, the object.
Correct. These lines also like it's dimensional line, so it will be thin. Okay. This is again a kind of dimensions because as I told you, thick lines are always showing the actual component, the edge of the component. Thin lines, It can be a dimension line, it can be a break line, it can be even a diameter, and so on. Do you understand? So any dimension line should be always mentioned or shown as a thin line. Okay.
Okay.
And what you've seen, the long break and short break, these are actually like a dimension line. This should be shown as a thin line, right?
Okay.
Okay. Okay. Now, can you see the
So it
video?
is similar to the thin
Yeah.
line.
Thin lines are thin lines are something like it's a description showing like how I want to show you about a component, and then when I show the component and sizes and shape also, then you should clearly find the difference. Okay, this is the component and this is the size. If both I give you the dark lines, then you'll be confused which one is the component and which is the dimension line, right? So that's why we make the actual component in a thick line, remaining all the dimensions in a thin line, right?
Okay.
Okay, right. Can you see the video? Can you hear it now?
What?
Okay. Can you see the video now?
No, no.
No one is seeing the video? No, okay, let me. All right, all right, all right. Wait. Share the application, share the audio, share. And now you will see that. Okay, let's start from here. Thin line, we'll start all over again, and let's go. All right.
leaders, hatching, etc. Next is a continuous thin freehand line. This line is used to show short break or irregular boundaries. Next is the continuous thin line with zigzags. This line is used to show long break.
See, that's a thin line.
Next is the dashed line. This line is used to show hidden edges of the main object. Next is the chain thin line, long dash dotted. This line is used to represent the center line for circles and arcs. Next is the chain thin line with thick at the ends. This line is used to represent the location of a cutting plane.
Okay. So this is extremely important that everyone must be knowing it. Okay. This is again I will show you. Just this one you should remember. Don't memorize it, but you should remember, because if you make mistakes in this, you will be losing plenty of marks. If you make mistakes, you will be losing a huge amount of mark on this. So I will show you again so that you remember this. Okay. Careful. I'll show you again.
Lines and types of lines. Just as in any textbook,
Listen
we are
carefully.
taught to use the correct words for making correct sentences. Similarly, in engineering drawing, the details of various objects are drawn by different types of lines. Various types of lines are used in engineering drawing. Now let us see the different types of lines. First is a continuous thick line. This line is used to display outline and edges of the main drawing. Next is the continuous thin line. This line is basically used for dimension, extension, projection, leaders, hatching, etc. Next is a continuous thin freehand line. This line is used to show short break or irregular boundaries. Next is the continuous thin line with zigzags. This line is used to show long break. Next is the dashed line. This line is used to show hidden edges of the main object. Next is the chain thin line, long dash dotted. This line is used to represent the center line for circles and arcs. Next is the chain thin line with thick at the ends. This line is used to represent the location of a cutting plane. Let us take a quick review of what we've learned in this video lecture. First, we have seen that engineering drawing is a type of a technical drawing which is used to clearly define the requirements for engineered items such as views, dimensions, and necessary information. It is also called as graphical language and helps to communicate. Next, we have seen different drawing instruments used in engineering drawings such as drawing board, drawing paper, pins, clips or adhesive tapes, pencils, T-square, set square, scale, drafter, roller scale, protractor, French curves, compass and eraser and their uses. Finally, we have seen different types of lines used in engineering drawing to draw an object. So this is the overview of our video lecture.
Okay, that's good. Right. So I hope you now understand something about lines, which are very, very important. Let me show you. Um, okay, let's see. Now we are here. Just before you go for a break, let me show you the one, and you go for a break then. Okay. Let me show. Okay. Now here you are. This is what you have seen now. Uh, a continuous thick line. It's a visible line. Then uh, a continuous thin line. This is dimension line, extension line, leader, and so on. Okay, there's a dimension line, extension, maybe some all this. The cut section line, the break lines, all are thin lines, like we see before. Then dash thick line is a hidden line, and chain thin line is center line. All right. So now and now you see there. Uh, let's see. So the part outlines are heavy, thick lines. Okay, we have seen it before. Now, if this is the part, this is a component. So these thick lines should be these lines, and the light lines are, say, the dimensions. Let's say this is 10 mm. So these lines are the light lines. The medium hidden lines are, suppose if there is a circular section is here, this line will pass through inside. So these are hidden lines. So this line is the hidden lines. And the center lines, or this line, this is the center line of this. So this center line is this one. And dimension and extension lines are this. So this is what you have seen it on the here. Okay. So this is very, very important that everyone must understand and keep it in mind until you finish this course from until the final exam. So this will give you, at least if you make mistakes, you will be losing 20 to 30% marks or only for this dimension line, thick line, light line, medium line, and I'm very, very particular on it. If you make mistakes with a thick line to the dimension line, you will be losing marks. So you have to clearly indicate a heavy line, section line, a hidden line, and center line clearly. Okay, I hope now you remember this. So the meaning of lines or visible lines or represent the features or the edges, like I said, edge, surface, is a circular feature. So this is generally about the feature. The hidden lines are that cannot be seen, the features which cannot be seen. The center line is the symmetry, path of motion, centers, circles, axis symmetrical parts, and dimensions and extension lines indicate the sizes and location features of a drawing. Okay, so those are the meanings of lines. So now you see here, before we go to that one, um, okay, I don't know. Let's see. This one is giving me trouble. So now you see the difference of different lines here. So the thickness, you see, the thick lines are given here. These are the thick lines. So you use always HB pencil. So when you buy HB, use this HB pencil only for thick lines or visible lines. So let's see. And the center lines as you see, the center lines are, these are the center lines. So this shows the axis line for a circle. See here also you have the center line. So the center line always look like this. Okay, this is center line. The leader line is the radius. Okay, this is the radius for this. So this is the leader line, thin line. The extension line for the dimensions is also thin lines. And the dimensions where you write, that's also thin lines. So only thick line you are using is for the shape. Okay, is that clear? So please, everyone must remember this before you draw this. Okay, that's very nice. Now let's go for a break. The time is now 6:12. You can come back by 6:22, exactly 10 minutes. Thank you very much. To perpendicular lines. And here the triangles are meant for making the set squares, which will give the 45-degree. Suppose if you use some of these things are 45, and this here it is 30, 60, and 90. Here also it is 90, 45, 45. If you want, these are some standard angles. You can make it by using the set square, and T square is meant for what do you call it, perpendicular lines. The drawing tool, this tape generally used to, just temporarily paste the paper on the uh, drawing board. Then 2H for thick lines, 4H for thin line. So when you go to buy these pencils, you better try to buy the mechanical pencils, which is much better than this pencil. So in the Jarir or any online, you just try the mechanical pencils. So the mechanical pencils, and you ask them to HB, and 4H. At least you need three sets of this. This is required. Okay, and this is like the secondary school students are using. So I would suggest not to buy this. If you buy, or if you already bought it, it's okay. But if you want to buy now onwards, try to buy the mechanical pencil. That is, it will save you a lot of time, because you're not a secondary school student to use this to, to make this as sharp. Don't use a sharpener. So better buy the mechanical pencil. So with 2H, HB, and 4H, 2H and HB is for thick line. This is for thin line. So this is another very important. Good. Point 0.7 is good. 0.5 it will be much better. Yeah, no problem. It's good, good. That'll be much better. Okay, so drawing tools. I'm sure that you must have bought this also. These are some of the the campus that is used to make the circles you have seen just now. This are you have seen. Uh, the drawing tools. These are some of the tools used to make the small curve, then the arcs, and so dots and so on. So this is not necessary, but anyway, this is for professionals. It's not necessary for you. This may be necessary. This is necessary. Yeah. In order to make the circle a standard circle, you can buy this. You can show it to the shop, so you can buy this. This may be necessary. If you buy this, it will save you some time. Yeah, these two are very important. Anyway, you already bought it. Lettering now. The next most important thing, how to, because I told you engineering drawing is about two languages included together. One is the written language or writing language, other one is the graphical language. So for the written language, lettering is very important. There are several types of lettering. Um, this is to communicate non-graphic information such as dimensions, axis, sections, and so on, projections and all. So it should be very, very legible because remember, whenever you make the drawing, this drawing is not meant for you. This drawing is meant for someone else who would try to understand your drawing. That is basically a communicating tool. So you should remember always that your communication should be clear, legible, uniform. Shape, size, all the things should be uniform, and you have to make sure that someone is going to read your drawing. He has to understand. So don't make him confused. You have to clearly mention what you are trying to or what you intend to communicate to the other engineer. So this is an example of a typical drawing, a technical engineering drawing. This is what you're going to use. Not necessarily these lines you don't need to draw, but definitely first thing you have to do is to draw the boundary or draw the marginal boundaries. So if this is your drawing table, so first thing, like I mentioned earlier, you have to get 25 millimeters here, and then another 5 millimeters, 5 millimeters. Then you fix your paper in the board, and then first thing you have to do is to draw the margins. These are the margins. So you don't need to draw the double margin like this. A single margin can help. That's it. Okay. So the margin, and then this is the drawing with certain views, and this we will learn it later. This is the cut sectional view, and this is why I told you there are several views, sectional views. Here are some of the instructions and notes. The title block, which is the name of the drawing, the type of drawing, the number, the metric, the materials number, everything. So about this particular drawing, the details are here. So it's like naming, like everyone has the name. So this drawing also has the name, and other details are given here. Okay. Then the component name, company name, who draw it, who checked it, who approved it, right? So in the industry, normally someone will draw. The usually it is drawn by the draftsman, checked by the supervisor, and then approved by the manager. So it's like two, three signature will be here. So that is also provided in the drawing. Okay, the drawing release time, this, that. There are several other factors. So that's all here. Okay. So this you should. That's just an example. So all your drawings in the future, when you submit it online, I always check for the first thing I will do is whether you make this line. Okay, whether you made this margin first. Mark, one mark is given for the margin, and then I will check the title block. So 2 or 3% marks for it, and then your views, whether it is thick line or thin line. Did you mention it? We don't. Yeah. Now, right now, don't need. You don't need it to do any block now. No, no. Unless I ask you, you don't need. But whenever you submit your exercise, it is a must because here you write your name, your metric number, and the exercise number, date of submission, all those things. So it is required whenever you do the exercise, homework, exam, quiz, and so on. So this is very important. Okay. Clear? Good. Lettering standard, American standard. So we are using in this course any of this. I don't think this will be very important to you, but anyway, capital letters, and then use 3 mm for most of the text height. So this is for professional engineers, but for us now, according to the ANSI rule, American National Standard Institute, They have used a Gothic style. It's like text. What kind of text style? Capital letters, all capital. Then the text height, like if you say dimension, if you write like this, it all must be capital. That's what it says, and the height should be 3 millimeters. Okay, that's what it says according to the ANSI standard. And the space between the text is at least one third of the text height. That means this gap between this for each one should be at least one third of this height. Don't worry about this right now, but these are some of the standards you must be knowing this. For ANSI standard, the lettering must be following certain standards. So how to write the uh, letters? I think so. This is pretty easier because you all know this now, because you are in a university, so I'm sure you know what is it. So the letter I, the A is first draw horizontal, vertically down angle line, another line here, and then like this. Then B is first you draw like this and make this first and take this as second. So what? How many lines I used? One is straight line, a slanted line, a horizontal line, and a curved line. Okay, all these strokes. Strokes means you know what is stroke. When you write a letter, you write like this. So this is on stroke. A, and then I, J, B, C, D, something like that. So this is something about related to the strokes. Okay, so this already you know that, but the problem here is you are not writing it like as usual in a paper. Okay, so you are writing it in a drawing sheet, so it should be very legible. So don't take a paper and write, oh, this is my hand. You should not write like this. This will get you 0 mark if you if you write something like that. Remember, you are writing in a professional drawing sheet, and so you should follow very clear instructions that you should follow the standard. So I should be like this, A should be like this. So it's not as you wish. Somebody write like this, somebody like this. So these all are wrong. You will be losing marks. So when I say ANSI, ANSI means you have to write like this. So it's a general rule that all your drawings must use capital. That is always better for ANSI standard. And of course, we are using the small letters also, lowercase. But if you are using the uppercase or capital letters, this should be the the method of writing it. Okay, X. It's very easy. A, E, L, V, H, and then F, T, W, and so on. This already you know that. Yeah, you can use the tool. Yeah, if possible, you can use the tool. No problems. Okay, this is for those who try to write in freehand. Okay, good. You can use the tool also. What he was asking me. The tool. Just a second. I'm calling. Once. Salam. Good evening. And what about those practical sessions? That's also included. I see. So we don't need to take the laboratory classes on our own. Yeah. Okay. Okay. But the experiments are going to be in our university. Is that so? Physically? Yeah. Correct. Correct. It was a fluid. Yes. I have nine students. One nine, other is 11 students. So, but the library is at 8 o'clock. 8 o'clock in the morning. I see. Oh, okay. I see. Okay. Mm-hmm. Okay. Okay. Mm-hmm. Yeah, the 10 meters. Mm-hmm. All right. All right. Mm-hmm. Mm-hmm. Right. That's okay. Mm. No, no, no. I understand. I understand that. I understand. Don't worry about that. No, just I was wondering. Are you aware of this thing, this schedule? That's what because initially they give another. They removed the senior project, and again they put another drawing, engineering drawing class. Yeah, I know. I know. I know. I know. No, no, it's fine. It's fine. If you are aware of this, no, I was wondering. Are you aware of this? If you are aware of this, it's fine with me. Nothing. No problem at all. Mm-hmm. Mm-hmm. Yeah. Okay. That doesn't matter. No, doesn't matter. Doesn't matter at all. Doesn't matter at all. Because last week I took a class for the engineering drawing. I finished one almost half of chapter. Then they removed the class and they put another one. So and then engineering design because I started right from the beginning. You remember last week I finished. Yeah, yeah, uh, yeah, 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 uh, yeah. And another thing is they give engineering design. Then I took all the materials from Dr. Halim and I prepared for the slides, and then suddenly it removed. So then I was, oh, what is happening? Okay, then I thought I never want to disturb you, you know that. But then I thought, okay, is it under you? Are you aware of this or something happening? That's what I just wondering. Okay, no problem. Okay. Hmm. I see. Mm-hmm. I see. Okay. Absolutely no problem. Okay, what about this? Our government has decided to go for physical classes, or still we are hanging on this online classes? How long? Any idea? Okay. Absolutely, yeah, yeah, right, right. So, yeah, so, mm, which means, which, which means this semester is going to be online. Yeah. No, 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 no. Last time, no, no. Last time I did this online. Last time in fact, much better I did because I downloaded the. Yeah, yeah. That is actually easier. Yeah, we give some videos, and I gave them, some exercise to bring the data from the internet and then we made the calculations, and then I showed the video how, because this is very related to the fluid mechanics, like measuring it. We made it, and Viva was for each one 15 minutes. I asked them questions. So, possible, possible. Yeah, absolutely. Yeah, right, right. Yeah, okay, okay, okay. No problem, no problem, no problem. The class is going to start. Yeah, the class is going to resume. Okay, thank you very much for calling. I'll continue my class. Thanks for calling. Thank you so much. Okay, bye bye. All right, no problem, no problem. I'm sorry, guys. I'm really sorry because this is the chairman was calling from the mechanical engineering department. So it's about the how we conduct the classes. So he was checking. So bear with me. Hope you don't mind. Okay. All of you are here. Can you hear me? Sorry about it. Sorry. Okay. Thank you so much. Thank you so much for your understanding. Yeah. Yeah. Right. Right. Because the chairman wants to know how we conduct the practical classes and so on. So it will be all right. Okay, so let's continue our discussion. Like this is how we write with the strokes. Strokes means how you make this lettering. Lettering is very important. You know why? Because most of us do not or could not write legibly. Even me, when I was in good mood, I write very clear. But when I'm when I was angry, or when I am, it depends on your mood. Then I write like this. The point is, this letter must be understood by somebody else. So I make a standard such that there should be a proper way of writing the letters even. The point is, no matter what you think, the idea must be communicated to the other guy. So we made even a standard for writing the letters. That's the idea. You got it? So whenever in your drawings, it's always better to write very clearly. If you are very confident about your own writing, it's fine. Otherwise, better buy the tool for writing. Okay, the tool is like ABCD. You will find it many templates. We call it as templates. So go and ask for templates for capital letter, capitals, and small letters, and so on. So you can use this in order to write, uh, in a proper way. Okay, you understand, right? It's this also, you please try to buy it from the store. They have several templates. They have A, B, C, D, so you can put your pencil inside and you can draw simply by following the template itself. Okay, that's another way of improving your writing, because no one is writing freehand in an engineering drawing. If your writing is bad, you will be losing marks. Do you understand? Hopefully, yes. So the stroke sequence I, L, T, F, and so on. Then now you see E, H. I think this is pretty easier if you have a template. But if you want to write in a on your own, so you must be very careful. Suppose if your name is Ahmed, you should write very clearly Ahmed, provided that this height must be 3 mm, like I said, for ANSI standard, and there should be gap, and it should be very legible. So, oh yeah, you can go for prayer at now it's 6:47. So you come back by 7 o'clock. Is it fine, all of you? When we'll meet? At 7 o'clock. Okay, we'll meet at 7. Okay, go on, no problem. Okay, go for it, go for it. Good, no problem. Go for it. Discussion about the lettering of engineering drawing. So everybody in now? Shall we continue? Good. All right. Okay. Oh, fine. So the most important part of this particular discussion is, like, whenever you use any lettering in a drawing, you should be very clearly indicate what you are trying to communicate. So that's why we have standard even for the letters, because letters, when you write, each one has their own style, and depends on their mood, sometimes you write very differently. So that's why we made a standard, even the letters. So in your all future exercises, the lettering is extremely important. So that's why I would suggest you to buy the template, and if you try the freehand, you should be very careful, because this will reduce your marks if you make mistakes in the writing. Okay, so that's why this particular slide is about, how to write each and every English letters in capital. The stroke sequence is given. You can check on your own, because I'm not going to stick on more on it. C, G, how they put the C, and Q. So now you can find, like, C, how the sequence is. But if you are using a template, it'll be a lot easier. Just put the template, and most of the time now people are using a template even in the industry. So it's better to use a template. Unlike similarly D, U, P, B, or J, those are the capital English letters, and then of course numbers. So numbers are 1, 2, like that. Then when you have 5, 7, the sequences of S, O, 3, 6, 8, and 9, and then very similar for the lowercase and higher and capital letters. So very similar to many of this. So please go through this, because it's not a very big task for you guys to follow. Let's go to the most important. Excuse me. So now the next one is spacing between the letters, because spacing is also very important. The point here is, whenever you write your word letters in an engineering drawing, you should make sure that enough or proper space should be given between the letters. So there is always a chance that if you combine it like J and you combine it like K, it doesn't make any sense sometimes. So if it is J, I, A, clearly there should be some gap. Otherwise, people will not realize the different letters. So sometimes we make mistakes, like this is I, and I can become K unknowingly. So the space is very important between the letters. There are two different and many actually non-uniform spacing and uniform spacing, but generally for uh, the engineering drawing we are using um, uniform spacing here. Okay, although both are most of the time it depends on the individual designer, but it's better to use standard uniform spacing. It looks better. Uh, but again, it depends on the letters, right? So since this gap is much higher, so normally they give this. So this is a standard, but on practice you will know better. Okay, the most important point is that you communicate your idea without any confusion from your lettering. That's the idea behind this. Okay. Uh, now, uh, so some of the space between the letters depends on the contour. Like this is the contour between them. So good spacing creates approximately the equal background area. That is the idea. Suppose this is the contour between the letters. So it's the better practice is the area should be uniform in between these two. So that is the best way of writing it. I hope you understand what I'm trying to say here. Because the letters are not uniform, or A, if you see there, this gap is different, but this gap is too huge. So you have to make sure that this should be uniform in such a way that it looks legible to the reader. That's the idea here. The thumb rule is just the background area should be approximately equal. That's very important. Okay, this is space between letters. This is a straight space, slanting, then curve. I think for you, if you use the template will take care of this. So I suggest everyone use template for lettering. Okay, so that because the template will take care of all this spacing, whether it is straight or slanting, inverted slant, and a curve. Everything will be taken care by the template. So I would suggest you guys to buy a template in order to get good grades. So those who are concentrating to get A plus, A plus, you must buy a template. It is a lot easier for you, and it will save you time, and also it will fetch you some grades. Otherwise, if you try freehand, might sometimes the size. There are standard sizes. You can go there, ask them the 3 size, and other one is 3, 5. It's similar. If you buy 3 and 5, should be fine. Okay. You can check it in the internet because I'm not going to show everything because I have to finish this course in time. So if this is a pretty easy thing, so you can find out. Go and ask that guy, and this is very very cheap. Maybe two real, 3 real only. One template, not more than 5 real. So you can buy 2 or 3, maybe more. It's not going to be very expensive. It's going to be very cheap. Okay. If you buy cheaper, you have 2 real template also there, 2 real, 3 real. So you can buy maybe one or maybe more. Okay, so it's better. One is for the capital letters, another one is for the small letters or the low scale letters. It's better to buy a template so you can save time and even you can get some grades better than the rest. Yeah, this and all. Now the good and poor lettering. This may be very important. You see, when you write freehand, this is good. You know why? Because the size here is uniform. This is 3 in this case for ASN, I mean ANSI standard. And see the gap between these is very, fine. uniform. So it looks very cool and very good. But see this one, small s, small t, small I, big T, small a. If you write like this, you will be losing grades. It will give you low grades. So careful that it is better. This also non-uniform, wrong. See, there is an inverted I. T is it's not only inverted; it is badly written. And here also the thickness. You see the thickness; it's not uniform. So you should take care of all these issues whenever you write this. This also you see here, the gap is not uniform. Now compared to this is wrong. So all these will give you lower grades. So careful. And the area between the words, now you see there. Here big area, small, big, small, big. So this is also wrong. All right. The point again, I would insist that the idea is to give the reader a clear communication so that there will be no confusion on how to interpret what you're writing, what you written. Sentence composition, all dimensions are in millimeters. So this is a very important indication you have to give in all drawings. You don't need to write millimeters everywhere. It is understood unless otherwise specified, all dimensions are in millimeters. Just keep it in mind. You don't need to write whenever you make dimensions, suppose like this, you don't need to write 10 millimeters. This is not necessary. Simply write 10 because it is understood that all dimensions are in millimeters unless otherwise specified. If it is inches, you have to write it. If it is in meters, you have to write. And the space in between these lines should be uniform, one space. And then, okay, so that's all for the basic uh, requirements of, or as you say, an introduction to the engineering drawing. So we have finished that basic introduction thing, or the what or the information you might need. So any questions so far, please let me know, because before we go to the freehand sketching, if you have any questions, queries, just let me know. Because we are coming to the conclusion of the first chapter almost. So if you have any question, please let me know. Okay, so if you don't have any questions, means you don't understand anything. Huh? I hope not. So let's see. Freehand sketching is the most important according to writing the letters. Yes. What is that? What's your question? Can you explain a little more? Your question. What is the question? Is you're typing, huh? Okay. Now freehand sketch, as it mentioned, it's freehand. It's very important because most of the ideas coming from the human brain, human mind, and immediately they start just scribbling on a piece of paper, and then they will enlarge it or they improve it, they develop it to a new idea. Is it possible that every letter should be 100% accurate? No, absolutely not. Obviously not. But at least it should be neat, clean, legible. At least you should not make mistakes. That I will should not make mistakes. Otherwise, okay. Okay. Make sure that you don't make any mistake. Then small mistakes I would normally agree, because since you are a student, I will not mind. Okay, don't make mistakes, big mistakes. All right. Good, cool. Now, freehand sketching is very easy. Uh, how you should draw a freehand sketch? So hold the pencil naturally, spot the beginning and end points. So if you want to draw a line, so just Keep it straight. So you know what is the starting point and the ending point. Swing the pencil back and forth between the points, barely touching the paper until the direction is clearly established. Draw the line firmly. So this is there's no specific instruction to draw. It depends on person to person. The point is, some people are very good in freehand sketch, and some people are not. The point here is just you have to be sure that uh, the freehand sketch what you're trying to make out, maybe at least it makes sense to the other guy what you are thinking, right? So if it's a straight line, draw a straight line approximately something like that, but don't draw like this is not a straight line or this is not a straight line. So that's the idea. So I cannot give instructions for the freehand sketching like this is the specific instruction. No, because it depends on person to person. But anyway, these guidelines will help you more or less to make a good freehand sketch. So swing the pencil back and forth between the points. You were what he was trying to say. He is trying to say this is the then freehand like the strokes. So this is a freehand sketch. So some people are very good at it, some people are not. So and the wrist movement should be free and easy. Let's see how he has given. Yeah, see that this will help you anyway. The horizontal line, how he draw a horizontal line. So first he make a point here, another point, and then he join it. All right. Even for me, it's very difficult because I'm using an electronic pen. So it's quite difficult, but in a freehand, it's going to be easier. Um, and vertical also, just make sure that the starting and ending. So you try to keep the pen free so that it's a freehand sketch. So you just draw it freehand. It should be your stroke should be as free as possible, and it should make sense. Another idea or some tricks are the vertical inclined lines, how you position your hands. So again, mark it something like that, and freehand you can just draw it like that and something like that. But whenever you draw, it should be straight. So keep your wrist free so that you will draw it freely. Okay. So this inclined lines and almost straight lines like this. Okay. Right. So a small circle, it may be a little difficult one. Drawing circle is the most difficult part. So one way is just to make a square and make these 4 points and try to draw. This is the easiest way. So then this will be easier. Or you take an arc here and then join it. It's much easier. This is also a freehand sketch. So finally you dark it. Okay. So first lightly sketching the square and mark the midpoint. Then draw the diagonals and join the diagonals. Okay. We did first make a square. You understand what I'm trying to say here? Make it and then straight it. Uh, did we need to buy? Yes, we need to buy. You want to buy the freehand sketches? No need. Freehand sketches you cannot buy. What are you talking about? What do you want to buy? Freehand sketches? I'm joking. Don't worry. Yeah, this freehand sketches are meant for freehand, not for using any other means. Okay, so don't worry now. Then small circle. How we are making, guys? I think you are confused what I'm saying now. This is freehand sketch. Let me show you because you're confused now. Okay, what I'm saying. Uh, what the freehand sketch is? Okay, I want to draw. Let's say a freehand what you can draw. I draw a very simple thing is a box with two holes. So what I do first, I want to draw a small box. So first I mark it and then straight line. I mark it here, another straight line, and join this together. Right, this is a freehand sketch. And then I mark an inclined line, another line, another line, then join it. Now it's a box. Then I want to show something here. So that is a hole here, that is another hole here, here there's a circle. So this is a freehand sketch. So here we are teaching you, we are trying to find out how to draw this freehand sketch. Okay, suppose I want to draw a circular, a cylinder. First, what I have to do, like he was saying, so first make a square, and then connect, make it the center. All right, then connect this here, and then join these lines. So now I got this the circle, and then I extend this to here, and then make an arc. So now I draw a cylinder by using freehand sketch. You understand what I'm trying to say here? So here they give instructions how to draw the circle, how to draw the square, freehand. Because immediately some idea comes to your mind, then you want to show it to the people. Then all you have to do is to remember. Yesterday, last time I said, this is the, what is this? Remember this, right? The Malaysian Twin Towers. So that is how freehand sketches or something like that. Okay, good. Any questions? Not. Good. Let me continue here. So a small circle, how can you make it? So either way you can make it. Draw, just go through this, and then draw another one, and mark the lines here. Okay, so you join it, and you get a circle. See? So this is the techniques for. Okay, so this is how. When can we draw online? Don't worry, I will give you clear indication. Next class probably you have to draw these things. I will give you guys, all of you, next class I'm going to give you an exercise of freehand sketches. That will give you like 5 marks maybe next week. So be prepared. Next week, within 1 hour or 2 hours, you have to draw a freehand sketch. Okay, be prepared. All right. Now, what is this? Okay. And then the last circle, how you can make the. And next week, can you repeat? Yes, next week, next class, exercise on freehand. Okay, freehand sketching. So bring a paper, just A4 sheet. Normal sheet is okay, and you draw your freehand whatever I give and submit it online. So you will get some marks. Yeah, you have to draw in the class. Yes, yes, yes. You have to draw in the class. So bring a pencil and a paper. Once you draw it, copy it and upload it to the blackboard. You will get some marks next week. Right. So arc. Arc means you know that arc is radius. So the arc can be drawn like this. First make a square and join this. So first make a square of the radius and join it. So this is how you make the arc. So other way to make an arc is you first, this is the radius here, and then draw a a line which joins the this these two maybe, and then your radius should be marked here and join it. So this is another freehand arc. So if you do this, this is some radius 10 or something. So this is an arc. So in order to make an arc, so first you measure the radius and then make the square, and then take this as center and draw this. That's one way. Or you take another square, connect it here, and then make an arc like this. It's also another way to draw. And these lines should be thin lines, and these lines should be thick lines. So that you should keep it in mind. Thick line always, you see, you can see this is thick line and this is thin line. So far what we have seen like how to draw the square, rectangle, then circle. How you can draw this circle? Circle is just to make the diameter and equally, and then you make like this. If it is radius, then again you make the, and then measure this and draw this. So these are the way how to draw this radius, I mean arcs and full circles. Okay, the steps in sketching is block in main shape, locate the feature, sketch arcs, sketch lines, and so on. It depends. There is no hard and fast rules, but it's better first draw the block, then locate the feature, sketch it, and sketch the line. Now you see, this is a homework, but you can try it now. Okay. All you have to do is to draw this. So how can you draw? Because there is an arc here. So listen carefully. This is an arc here, another arc, a full circle, right? So you can make a square for this, and what else? So for this you can make a square. For this you can make a square. For this you can make a square, and for this also. So and then maybe you can do this, and this is also an arc, so you can make another square here, so you can draw it. Do you understand what I'm trying to say here? So what I do first, make the block, the big block first, and then wherever the arc is there, you have to draw the square. Either way, you can make an arc like this also as well. This is easier. Okay, I'll give you this now. Just keep it to try. Don't submit to me, but try this and let me know. Go for it first, okay? Come on, there'll be another 20 minutes. Draw this. If you have any problem, just let me know. Yeah, no tools. Freehand. No tools. Free. Yes. Freehand. Right now, yes. You don't need to submit, but you draw, and if you have any doubts, ask me. Now, start. Any paper. You are not going to submit to me. No grading, just for your exercise now. Start drawing, and if you have any doubts, let me know. So now, this is the arc. So let's see. So if you see there, this is some arc. Let's see. So how can I draw this? Oh, how can I draw? So first you draw this line. Then draw this. This no, not this, not this. The previous slide, not this. It's just okay. You can go back. Yeah, right. Don't you find it in your? I told you to bring all the slides, right? Try it now. So make the squares wherever necessary, and then you draw it. So the red color lines are for making the arcs. Yeah, right. Actually, you have to draw this. So in order to draw this, you are this is the way you draw in a freehand sketch, but this is what you need. You understand? This is the method. Freehand. This is the one. This is the exercise. Guys, I hope there's no problem in drawing it, right? The point is, whenever you draw the arc, you have to make a square, and you have to draw accordingly. Okay, so that's the idea. So in the next class, there will be an exercise on freehand sketch. I will give you a very similar one, and you have to draw within the class itself. You have to submit it within 1 hour.
Doctor, should we also draw the right one?
Not this. Next class, you have to send me the freehand sketches. That's an exercise, so I will give you grades for that. Okay, not this
Yes,
one.
but should we draw it like the right one, right? Or the left?
Yeah, the ordinary paper in your white sheet, some white sheet, no A3, just a freehand. Take a white sheet and draw by using a pencil, and then scan it and submit it to the blackboard. That's it.
Mhm. Okay.
Okay, so the timing is very important. If you submit later, then it'll be a problem. So the blackboard will stop exactly at the time, so you have to submit it before the time. Whether you finish it or not, once you whatever the time, just submit it. Otherwise, you will be losing the grades. Okay.
But I have difficulties with drawing the circle and
Yeah. No problem. This is freehand. There'll be not no marks for your it looks great or not. It's just how you are trying to draw. That's the most important part. Okay. So like this, you may have find it to make a perfect circle. That's fine. But what is most important means whether you make the correct it, connect it here, and then you mark it here, and then you join it. This is what I'm going to see. Okay, this is good. I think this is good if you do that. And if it's an arc, just make a square with the radius, and then whether you make an arc like this, that's very important. So this is how I will check it. Nothing else. Okay.
can you repeat it again?
Suppose if this is the one, next week I'm giving you an exercise like this. Then what you have to do? Let me give you a simple exercise. I will show you now. Okay, next week, just say this is a model. Let's say model exam. Okay, in the model, I give a free sketch. So your exercise is okay. This is the exercise. You know how do you draw? This is the exercise will be given in the next class. So how you will draw this? Okay. So no need to. Don't send anything now. No, and don't send anything to my email ID. I will not check my email ID. I will not check anything. You have to communicate to me through only the Blackboard. Don't try to send me to my email. I will not check. I will not give you grades. Be careful, everyone. Don't check anything. Don't send anything to my email ID unless it's absolutely necessary. Okay. Exercises, quiz, exams, don't ever try to send because this is through Blackboard. Okay. So now how I will draw this. So first I will measure this. Okay, from here to here. So and what I will first do, I will mark a line and another point here, another point here, another point. So first I will straight a line and join it here. This is the first step. And then I have a radius here, right? So this radius, I will measure this radius, then I will make one here, not here, maybe yeah, I will mark it here. So I will mark it here. So I will make a rectangle here, then I will join it, then another rectangle here, then another rectangle here, another rectangle here, another rectangle here, and if I join it here, so another rectangle here. Okay. So first I will make this, and then I will try to draw. First I will no need to draw because that is simply, so I will join it here, and then from here I will make a arc like this, and then join it here, and again I will make another arc, right? And then I will this is the arc, I join it here, another arc, join it here, another arc, and here another arc, not here, maybe then that'll be somewhere here. Okay, and this is something like this, another arc, and join it here. So this is my final drawing. So this is how you have to make it. It's not very clear, but this is the way you have to, because my electronic pen is very difficult to draw, as you see. So, but that is how you have to draw. That's the idea. Okay. Okay, guys. Hope everyone know something, at least gain something, learn something today. We will all meet next week, same time. You bring your white sheet and you draw an exercise, maybe 1 hour, and submit to me. So you'll get maximum 2 to 3 grades next week. Okay, just a freehand sketch. All I need this kind of drawing, because I want to know how you draw the scale, the radius, and probably I'll give you this radius. If the radius is given, it's fine. Otherwise, simply make the freehand sketches like this, and you will get some grades for it. Okay, never try to send to me through email. No, email, no. I will not accept any email submission. Only Blackboard. Okay. Okay. Now we come to the conclusion of this particular class. Any questions from you guys? Any questions? Any queries? What we have discussed this evening?
Doctor,
Yes.
next class we will use tools or freehand.
Freehand, no tools.
Okay, okay.
Just bring a pencil and maybe a small scale, because to make this rectangular this square, we need a scale. You're not, and you don't need to do. You don't need to use the scale also. If you do it with freehand, that will be much better. Okay, you don't use any tools. Just use your freehand. So you are
Okay,
okay.
okay.
Good, guys. Thank you so very much. Thanks for your cooperation, and I appreciate. So we'll meet on next class. Until then, good night and goodbye. The class is dismissed. Thank you so very much.